everyone. Today's lecture is going to be about thinking and problem solving. This is going to be the first of two lectures about cognitive psychology. So, getting started today, we are going to look at kind of how our brain organizes information. And so, you've heard me say many times that it's pretty fascinating that I can say something like, think about your address, and you can immediately think about your address of your home. And you have billions and billions of pieces of information in your brain, and yet you can find that very specific piece of information very quickly. And it's because of our brain is really organized, our mind is really organized. The first term here we've talked about several times. You should hopefully by now be familiar with the idea of a schema. And I often give the analogy of a schema being similar to like a file that you would find in a file cabinet. And so we haven't really spent a lot of time talking about, well, what's inside of those schemas. So the schema for this example we're going to use is going to be household pets. And so if you can think of a file cabinet being your mind, and we open up that file cabinet and we pull out a file, and the file is labeled household pets, right? That's our schema. Then think, well, then what would go inside of that? And so kind of the next tier are what we refer to as concepts. Concepts are like the files that go inside of a file folder. And so if your schema is household pets, your concept might be dogs, right? And you've got lots of concepts in that schema. You've got dogs and cats and birds and fish and all those wonderful things. And then further down that kind of linear progression of how our mind is organized is the idea of a prototype. And so for all of the concepts in our mind, we have prototypes. And prototypes you can almost think of as like the average. And so in your mind, you have a schema for household pets, which has concepts including dogs and cats and fish and birds and things. And so if you take the concept specifically of a dog, you might have in your mind this very stereotypical dog. And when you think of dogs, that's what you think about. It is a prototype. Recognize that the further things are from our prototypes, the more difficult they may be to conceptualize. And so I have this really ugly looking dog that shows up on the screen. My face is kind of covering it up. You can call me the ugly dog. And how that dog may be really difficult to conceptualize because it's likely very dissimilar from the prototype that you have in your mind. And you can do this for all different kinds of schemas, right? In your mind, you have schemas for musical instruments. And so concepts would be violin, piano, guitar, things like that. And then for each of those instruments, you have prototypes, like a very stereotypical representation for what that item may be. And what this does is it allows our mind to be very efficient. It allows us to very quickly pull up pieces of information. Now, sometimes we're put in situations we need to problem solve. And when we are in situations where we need to try to problem solve, there are some different strategies that we can use. Here I have this guy walking around a grocery store. Where's the apple juice? Do I look on every shelf in the store? Do I search where there's similar stuff? So one way that we problem solve is through trial and error. And the idea behind trial and error is that there's no pattern. There's no guaranteed solution. You try something, it might work, it might not. And that's how we solve some problems. It's not a great way to solve the problem for the guy in the grocery store. Trial and error would be him walking around aimlessly trying to find, what was it that he was trying to find? I don't remember. Apple juice, right? And that's one way he could try to find the apple juice, but it's not a great way. Sometimes that's what we do to problem solve is we'll try something. If it doesn't work, we'll try something else. If you've ever been to like an escape room, we use a lot of trial and error. You're locked in this room. You're trying to figure out, how do I get out of here? And so you're picking up objects. You're looking under posters and things. You're trying to figure out, how do I escape? You try something. It might work. If it doesn't work, you try something else. Algorithms, on the other hand, is when we use a very set pattern for problem solving. And if you follow that set pattern, it will guarantee the right answer, assuming the right answer is there. And so in our grocery store example here, this man could go to the first aisle and look on the top shelf and look at every item on the top shelf. And if it's not there, he goes to the second shelf and the third shelf and the fourth shelf. And then when he's exhausted all of the options, then he goes to the second aisle and then the third aisle and the fourth aisle. And you can see that if he follows this set pattern, it will guarantee that he finds the apple juice, assuming the store sells apple juice. Algorithms work really well in math when we follow a set pattern. Um, know that it guarantees the right answer if there is a right answer. You could open up any combination lock in the world if you have enough time, right? You just start with 000, then 001, 002, and at some point you'll get to the right answer. I've got my phone right here. You could text me if you want to. You don't know my number, but you could text me if you have some extra time on your hand, and you probably have some extra time on your hand in this distant learning. Just text 000000000 and see if it's me. And when it's not, then you'll just go to the next number in the sequence, and at some point you'll get to my number. That's an algorithm. And then heuristics are shortcuts. We use heuristics all the time. They're cognitive shortcuts. They are tricks that we have used in the past that traditionally give us the right answer most of the time. If they didn't give us the right answer, we wouldn't use them. Spelling, for example, the old trick of I before E except after C. That works most of the time. If it didn't work most of the time, we wouldn't use it. But as you know, it doesn't work every time. And that's kind of the deal with heuristics. This guy at the grocery store looking for apple juice, he knows he should probably go to the juice aisle. It might not be there. Maybe they put the apple juice in the produce section next to the apples. But traditionally, it's probably in the juice aisle next to the orange juice, next to the pineapple juice. So it's a good place to start. That's the idea of problem solving using heuristics. I have two specific heuristics up here that we use often. We use what are called availability heuristics, and we use representative heuristics. I have some definitions for you, and I'm going to give you an example on our next slide. The idea of availability heuristics, this is a shortcut when we make decisions, we problem solve based off how easily something is available to us, how easily we can remember or recall information. For example, you may have just seen a news clip about a plane crash, and so you may overestimate the likelihood of a plane crash because you have this really vivid memory in your mind of what that's like. Representative heuristics is a shortcut where we base our decisions, we base our problem solving skills off of prototypes, off of things that represent or seem to fit what we expect to have happen. So, for example, if I were to ask you what's more likely to get pulled over on the highway, a red convertible Corvette or a silver Toyota Corolla, you might think Corvette is going to get pulled over for speeding. The reality is there are significantly more Corollas driving around on the highway, and so they're going to be more likely to get pulled over. But the Corvette represents speed. So when you solve that problem of who's more likely to get pulled over on the highway, or what are you more likely to see pulled over on the highway, you might think Corvette because it represents speed, when in reality it might be something else, right? So here's some examples for you. Sarah loves to listen to New Age music and faithfully reads her horoscope each day. In her spare time, she enjoys aromatherapy and attending a local spirituality group. Is Sarah more likely to be a school teacher or a holistic healer? She may appear to be someone who would be a holistic healer, but the question is she more likely to be a school teacher or a holistic healer? Well, ask yourself, how many holistic healers do you know? Maybe one, right? How many school teachers do you know? Quite a few. So Sarah's more likely to be a school teacher, but she represents what we expect or what we think about when we think of a holistic healer. So that's a representative heuristic. After reading an article about lottery winners, you start to overestimate your own likelihood of winning the jackpot. You start spending more money than you should each week on lottery tickets. So when you're thinking about this, maybe I'm more likely to win because, hey, this person right down the street from me won the lottery. Well, you overestimate your chances of winning because you can so easily recall that time that someone else won. So it's available to you. It's an availability heuristic. Now, sometimes when we are trying to solve problems, we run into obstacles, and we call these obstacles mental sets. I want you to look at this kind of shape that I have here. I say the picture below shows how to dissect the polygon into 4 congruent parts. Congruent being same size, same shape. Can you find the only way to dissect the same polygon into 5 congruent parts? This is one of those times I wish we were in class because I pass out the little shape and you all try to figure out how to divide it into 5 parts. And it's really tricky. And the reason it's tricky is because students try to come up with this weird design of how to dissect it. And you do that because you're given an example. And so you're trying to solve it the same way you've solved other problems. The reality is the solution's pretty easy. Here's the solution, right? Now, if I hadn't shown you this image on the left, it's a pretty simple problem. But I've given you an example, and so you're trying to solve the problem the same way you've solved other problems. This is what we call a mental set. A mental set when you try to solve problems the way that you have solved them in the past. If I get into an argument with my wife and then I go out and I buy her flowers and I ask for forgiveness and she forgives me, I've just solved that problem. Then the next time, if we get into an argument, I think, oh, I know how to solve this problem. And I go out and I buy her some flowers and I bring them home. And she says, not this time. And now I'm stuck. I don't know what to do. And I think, well, this is how I've always solved this problem. So mental sets are these obstacles that we face. You're trying to solve the problem the way you always have. And now you're stuck because you can't think of another way to solve it. Maybe you always do presentations in class using Google Slides. And your teacher says, hey, you can't use Google Slides for this presentation. And now you're stuck. You don't know what to do. It's a mental set. Another type of mental set is what we call functional fixedness. And the idea behind functional fixedness is when we look at an object and we struggle to think about how that object could be used for some other purpose. When you can sometimes think of like these life hacks that you see on the internet, right? Functional fixedness is when you are stuck looking at an object using its only purpose, right? You are fixed on its initial function. And so think about those times in your life where maybe you've needed a specific tool or a specific object, but you haven't had it, and so you've had to think creatively. Maybe there's a loose screw and you don't have a screwdriver, but you've got a penny in your pocket or a dime in your pocket, and you use that to tighten the screw. When you do that, we say you are overcoming functional fixedness. It's another obstacle that we experience. And then last slide for today, more biases. It seems like every other time we talk, we're talking about biases in psychology. So that first one is review. You should already be familiar with that. Confirmation bias. We're seeking out evidence that confirms what we already believe. If I believe that male students are more likely to fall asleep in class, I'm going to pay attention every time I see a male student getting sleepy. Maybe I kind of ignore the time the female students are getting sleepy. These next two are new terms, but they're relatively straightforward terms. Belief bias. If someone is trying to give us evidence that goes against what we believe, we have a hard time thinking critically. And there's countless examples of this. If someone tries to tell you something that goes against your political belief or your religious belief, you may struggle to think logically about what someone is telling you, or maybe something that you're reading or seeing on TV, because your belief is strongly pushing you to think this isn't true. I don't trust this. And if that continues, if that persists, and you are given lots of evidence against your beliefs, but you hold steadfast to those beliefs, we call that belief perseverance. So maybe you're a flat earther. I hope you aren't, but maybe you are, and you believe the earth is flat. And we just show you countless evidence over and over and over again about how the earth is in fact round, right? But you say, I don't care. I believe the earth is flat. We would call that belief perseverance. And so there's lots of examples out there with people that are very stuck in their beliefs, and they struggle to think critically about new information. And being skeptics and being open-minded about new information is incredibly important. And so I hope that you practice those things. That's it for today. I got to figure out how to turn this thing off, and so this should be humorous for you. I think I go here. Here it is. All right. Have a good afternoon. Bye.